Let us now move on to the impact of climate change on agriculture and biodiversity. To take us through this topic and to discuss a brief case study on responses, we have with us Dr. Rohan Pethiyagoda, one of Sri Lanka's leading naturalists and authors. He is the former deputy chairperson of the IUCN Species Survival Commission and a research fellow of the Australian Museum. Dr. Pethiyagoda has been responsible for the discovery and description of almost 100 new species of vertebrates from Sri Lanka, including fish, amphibians, and lizards. He earned the Rolex Award for Enterprise for his pioneering work on the restoration of montane forests, where he began an ongoing project to convert abandoned tea plantations into natural forests. His work is critical to understanding the process of restoration, which is now critical in building climate resilience and adaptation. Please welcome Dr. Rohan Pethiyagoda.
Thank you very much. First of all, congratulations and thank you, Dilma, for organizing this event today. It's a big step in the right direction. Very grateful to you. My presentation is not going to be about what you were told entirely. I want to draw your attention to a few facts that I think we don't pay enough attention to already. One is that in this whole climate change scenario, there is only one number that matters. As Dr. Punyavardhana said, the atmospheric concentration of carbon dioxide. Everything else you hear about climate change comes out of the wash from that one simple fact. That's a number that we all need to know. That is the pulse of the planet. So where we find ourselves today is at the right-hand corner of that graph. After the past 1,000 years of having an atmospheric concentration of less than 300 parts per million, we are now well over 400 and aiming for the sky. This graph shows you the past 800,000 years. We know atmospheric carbon dioxide concentrations for this period very accurately because of the data we get from Antarctic ice cores. And as you can see, in the past 800,000 years, bearing in mind that humans have only walked on this earth for the past 60,000 years, 400 parts per million is something we have not seen in evolutionary history. We also know that other key indicators follow the concentration of atmospheric carbon dioxide very closely. The second line there shows you average temperature, the temperature anomalies, and the bottom line shows you sea level. As you will see, as in the past 400,000 years, carbon dioxide concentrations have varied, global sea levels have varied by as much as 400 feet. So unless you've invested in one of the penthouse suites in the Altair, you best learn to swim. The last time atmospheric carbon dioxide exceeded 400 parts per million was 17 million years ago, long before many of the species that walk the earth today had evolved. And that saw a sea level rise of around 100 feet. The reason this is important is we are only tweaking one number here. We are tweaking greenhouse gases. So you have to expect that the other consequences of that tweak will follow. And that's what we need to plan for. So I was asked to talk about the impact on biodiversity. I can tell you the impact in one word: catastrophic. The worst impact, probably, and soonest, is going to happen in the oceans. The oceans today are acidifying at a rate that exceeds anything they have seen during vertebrate evolution. The last time oceans saw this kind of acidification trend was 252 million years ago, when the Earth saw the Permian-Triassic extinction. The acidification of the ocean means that all those animals that depend on calcium carbonate for their exoskeletons, whether it's mollusks or plankton or corals, cannot survive. The very bottom is taken out of the food web. When the Permian-Triassic extinction took place 250 million years ago, 90% of oceanic species became extinct. That is what we are looking at, unless and even if we reverse climate change as we see it happening now by reducing carbon dioxide emissions. Another simple case of impact on biodiversity is as climate warms, species need to adapt or move to colder climates. Now we all know that as you go up country, the climate cools substantially, about 2 degrees for every 1,000 feet up you go. That's why Norelia is about 12 degrees cooler than Colombo. So trees and animals and plants that are now almost at sea level in forests such as Carnelia, Narkedenia, Kottava, Singharaja, have to migrate upwards. But there are two problems. One problem is that we have fragmented our landscape so radically that the migration of species becomes very difficult unless we build substantial habitat corridors that enable this to happen. Messing with the landscape level interventions in Sri Lanka is now difficult because on average we have 400 people per square kilometer in this country. We're very densely populated. And the southwestern wet zone, which is where most of the biodiversity is, also has most of the population, often more than 1,200 people per square kilometer, which makes it a huge displacement problem. The other problem is that the species that live on the highest peaks, such as in the Horton Plains, have nowhere higher to go. So you're looking at extinctions there, and already if you go to the high country, you will see the impacts that we are facing, for example, with canopy dieback in places like the Knuckles and Horton Plains. So my response to this 20 years ago was to try one experiment to see whether a habitat corridor could work in the highlands. In the lowlands, we know this is possible. Sam Popham already in the 1960s did an experiment in Dambulla on a very small piece of land, 18 acres, which he successfully showed that within 20 years, you can have a dry zone canopy forest established. In the highlands, this is a much bigger challenge altogether. So that's, in the middle is 20 years younger myself. And we bought this piece of land in Agrapatana, 50 acres of it. And I put up my laboratory there, built some greenhouses, got seeds in from the forest, and together with germinating seeds and vegetatively propagating native tree species and plant species, planted out several tens of thousands of seedlings on this property. This is my private experiment. It didn't involve any state interventions. So that's now an aerial view of the property, which has got a luxuriant tree growth now. But unfortunately, what we find is that most of the native trees that we tried to cultivate simply won't grow. It takes a very long time. Many of the species of trees in the highlands are so slow growing that we cannot do it in 1 or 2 lifetimes of human beings. When you go to Horton Plains and you see those umbrella-like crowns sticking out of the forest, Calophyllum walkeri, the endemic tree that dominates our montane forest canopy, those crowns you're seeing are probably 300 to 500 years old. This is a very slow process. You can see this also in Horton Plains when you walk through and you look at the rhododendron bushes on the grasslands. Those trees started their lives when I was a kid and I used to go and play in Horton Plains. Now they're about 2 meters high in my 60 years. So while we can get tree growth, we can't get many of our native species to grow in these forest corridors that we are planning to, that one day, sooner or later, we'll have to do. The good news, however, is that the animals move in very fast, even to degraded forests. So our camera traps on these lands show that pretty much every species of animal and bird you could want comes in quite quickly. Out of the 15 species of amphibians that we find in the highlands, 13 colonize the property within just 5 years. So there's relatively good news for the animals. But nevertheless, we keep scientific records of pretty much everything that's happening, the dynamic of this property, and have been publishing these from time to time, because it's long-term experiments like this that will enable people in the future to design corridors, learning from our mistakes, and maybe utilizing the lessons that we have learned. So leaving that to one side, I want to return to the global scenario again, because that's what's really important. This graph shows the growth of carbon dioxide in the global atmosphere on a region-by-region basis. And as you can see, most of the countries and regions of the world have now begun declining their emissions. But even though Europe and even China since 2013 has reduced its emissions output year on year, even though those are reducing, what we have to realize is that carbon dioxide concentration in the atmosphere is going to keep increasing for a long time to come. And our part of Asia, which is right at the top there in dark brown, is set to increase for a long time yet. The reason is that our electric energy consumption even now is very, very low. Just 0.7 megawatt hours per year per person. To become a developed country, as we industrialize, we are going to increase that by 10 times. 1,000% increase in electric power generation is what we are looking at for Sri Lanka in the coming years. And even though at the moment we are generating a substantial amount of our power from renewable resources, about 30 to 35% of our power comes from renewable resources. Almost 50% of our capacity, our generating capacity, is now renewable. But of course, with renewable energy, you can never get 100% of your capacity every year, because you might not have enough rain, the wind might not blow, and you might have cloudy days and so on. But we can't increase the component of renewable energy very much further than we have now. We can tweak it a bit, maybe look at a growth of 30 or 40% a year. But when you're trying to reach 1,000% growth, 30 or 40% a year is nothing. So we have to think big into the future, because these projects, as I will explain in a minute, take a very long time to plan. Remember that just the Mahavali project, even the accelerated form, took 35 years of planning. And the only technology available at the moment that we can even think about that will provide CO2-free energy is nuclear. Now, this sounds like a frightful option, but 33 countries in the world have nuclear electricity, including countries that are substantially poorer than us. There is no reason we can't think big into the future. In fact, we have no choice but to think big into the future. But the problem we come across, as green as we are, as environmentally friendly as we are our colleagues in the environmental conscious community. In 2004, I was appointed to chair the environmental impact response for the government for the Apakot Malay Dam. Tiny project, 50-acre pond, but with massive electricity potential. That project was delayed for 10 years because of environmental objections. What did we claim, the environmentalists? There's going to be earth slides, there's going to be earthquakes, there's going to be huge species extinctions. Environmentalists went around burning tires on the streets for a 50-acre piddling little project. The interventions we need to engineer by way of hydrology, by way of energy for Sri Lanka to face the true impact of global climate change, those interventions are so radical that we have to get used to thinking big. The Lakvijaya plant at Norichle, 25 years, designed in the presidency of President Premadasa. Finally, it was only Mahinda Rajapaksa who was able to do it because the NGOs were frightened of him. Because we have to learn that if we are going to be hungry for energy, if we want to industrialize, if we want to provide the prosperity that people are demanding, we have to provide the energy. And if we can't provide clean energy, then people will opt for dirty energy. Think of the problems nuclear power faces. In 2011, the Fukushima reactor in Japan was shut down as a result of an earthquake. 1 hour later, a 50-foot tsunami swamped the station, and the station was shut down. Not one person died of that nuclear accident. 18,400 people died from the tsunami. But all people remember now is the nuclear accident, which didn't provide a single casualty. And while we have been taught by the global environmental zeitgeist to believe that peaceful nuclear energy is so dangerous, we all sleep happily at night, unconcerned by the fact that there are 14,500 nuclear warheads at play amongst the world's armies. If you plot those 14,500 nuclear warheads on a grid, on an equal grid across the surface of the Earth, that's what it looks like. And we sleep at night in the knowledge that there are 6 nuclear bombs, for example, if you just take an average distribution of bombs across the planet. So being frightened of nuclear energy is a bit like being frightened of flying. The more we learn about it, the less frightened we would be about it, and that's why we need to teach it. Last year, 2017, was the first year in history that not a single person died from a commercial airline accident. Not one. It was also the record year for the largest number of commercial airplane trips taken in the world. Almost 3 billion people took a plane trip last year, almost half of humanity. Not one person died. Why? Because over the years, we have refined our technology for flight, learning from our mistakes and taking the technology to much safer levels. So unless we try these things, and unless we learn from the 3 Mile Island nuclear accident in the 1950s, from Chernobyl in the 1980s, from Fukushima in 2011, unless we learn and we go forward to innovate, we will never solve the big problems that stand before us. We've done things like this before. Remember the 1990s and the Y2K scare? People thought the world was going to end, but computer engineers sat down and they sorted that problem out. In the 1960s, as a 14-year-old boy, I can still remember going and standing outside the cooperative at Timbrigasaya with our family's ration book to get rice. There was such a global food scarcity. People were starving. And at that point, there were only 3.5 billion people on Earth. The word famine that was commonly used when I was a schoolboy, I bet your children don't even know this word. Because even though the population of the planet has doubled since then, what happened? Very clever people all over the world, including in Sri Lanka, the agriculture department, produced magic. From getting 1.8 tons of rice per hectare in 1960, today we get 4.4 on average. Many rice fields are getting 5, 6, 7. Because when we set our minds to solve a problem, we can and we have. And the institutions that we have, like the Department of Agriculture, have really been magical in producing these results for our prosperity. Take malaria. Until the 1950s, thousands of people were dying every year. In 1958, more than 1 million people got malaria in Sri Lanka. Then the miracle of DDT was brought in. I use miracle advisedly because I know this is a dirty word, but I am fond of DDT. Because by 1963, we very nearly eliminated malaria from Sri Lanka. We had only 17 cases in that year of 1963. We were the poster child for malaria eradication across the world. What happened? A well-intentioned lady published a book. And the whole world went into a spasm and said DDT was bad. And still, the stigma is there with this largely safe pesticide. We lost our nerve. We stopped using DDT. And for 50 more years, malaria plagued this country. It was only finally in 2013 that the health department was able to get rid of it. So it's very nice to have these waffly ideas like our president has got. It sounds nice and cozy to say, I want to live in a world without pesticides. But the fact of the matter is these pesticides keep us alive. They keep us fed. And Sri Lanka has got a fantastic record for safe pesticide use. The statement that we are all discussing today is that there is solid evidence that the earth is warming. I think we all subscribe to that. But look at the United States. Half the people who vote for President Trump in the Republican Party don't accept that fact to be true. In the opposite party, the Democratic Party, 84% believe that to be true. How is it possible that in one country, a political ideology can divide people in their understanding of a scientific fact? We are at a similar crossroads in Sri Lanka. And the only way we can get out of this problem, the only way we can address climate change is by giving our children a scientific education. And I'm so glad that Dilma is doing that right now. Thank you very much.
Thank you, Dr. Pethiyagoda. You have given us a lot to think about, and we may not have a choice but to think big in light of the reality that we have to face now with climate reality and climate change.